Good afternoon, Physics 20. I hope you guys are all doing well today. We are today going to look at our fourth topic, and we've got our uniform accelerated motion notes today. So please enjoy the comic here. Make sure you guys have your data sheet and make sure that you guys have your notes around. I should probably make sure I have my data sheet. Yes, I do. I should probably have mine if I'm going to be doing some physics today. So, let us begin. Enjoy the comic. It's awesome. Foxtrot, always good. Alrighty-o. So let us look, ladies and gentlemen, at our formal definition here of uniform accelerated motion. Now, the key word uniform accelerated is in of itself rather misleading because our motion here is non-uniform because we're no longer covering the same distance over a same period of time. Our motion isn't the same anymore. It's accelerating. We're going faster and faster and faster, or decelerating slower and slower and slower. But it's called uniform accelerated because you're going to be speeding up or slowing down at the same rate. So this guy here, ladies and gentlemen, the acceleration is constant. Okay, so constant acceleration, but it is non-uniform motion, okay, because we're accelerating. So watch out for that. That's a little bit confusing. All right. Okay. So formal definition, acceleration. This is the rate at which an object's velocity changes. Now remember what that word rate means. Rate means over time. So velocity change over time. Gotcha? So, how much an object's velocity changes over time? It is a vector. Highlight that, emphasize it. You must know it. Less than subtle hint on test. If something's a vector, you gotta know it, guys. Now, with uniform accelerated motion, ladies and gentlemen, the acceleration itself is going to be constant. However, our velocity is going to change, okay? So keep in mind, uniform motion is when velocity remains constant. So there is no acceleration in uniform motion. Here we are accelerating. So therefore our velocity changes. Therefore, non-uniform motion. All right. Instantaneous velocity, something we use a little bit in Physics 20, not a ton. But it's just the velocity of an object at a particular point in time, at a very specific moment. So if you're accelerating and you want to know how fast you are going at a specific point in time, that's the instantaneous velocity. So that's why we always go with we need to specify our final velocity and our initial velocity when we're looking at acceleration, because our velocity changes, right? Final at a specific point, initial at a specific point, we got to use those two differences. Okay? Now, we've got a bunch of different equations that you guys can use, and these are all on your data sheet. Okay? Now, I want you guys to pull out your data sheet. I want you guys to find these, okay? So you will see this top piece under kinematics here, okay? You will see a whole bunch of equations. Now I'm going to pull out my pink highlighter here. I'm going to highlight these, okay? These are important. Anything that I highlight in pink are one of your 5 acceleration equations that you're going to be needing in this unit and pretty much every unit for the rest of the course. You need these equations. Love them. So look at your data sheet. Find everything that I've highlighted in pink here, okay? Those are your acceleration equations, ladies and gentlemen, okay? Those are your acceleration equations. Now, each of these equations are unique. they're all based off of using some calculus on your standard acceleration equation. We're not doing that. You just have to find them on your data sheet. All right. So now each of these are going to have 4 of the 5 of these items. So acceleration, time, displacement. Now with velocity, you're also going to have your final velocity and initial velocity. So each of these 5 items, of each of these 5 pieces of data, are going to be in these equations. But one of them is going to be missing in each. Okay, so we've got 5 acceleration equations that we are going to be using, and in each of these equations, one is missing. All right. So our most common equation now this is the one you would have used last year in Science 10, would be this guy here. So your delta V over delta T. Now, ladies and gentlemen, what does delta mean in Latin? Change in. Good. It means change in velocity. Now, anytime you have a delta, what can you do with that? Same thing we did with delta D earlier. Expand it. Good. So the other way that you can write this is your acceleration as VF minus VI over your change in time. Okay, this is where you get all 4 entities: acceleration, final velocity minus initial velocity over time. This one's on your data sheet. This one is not. You need to know for the rest of the course and the rest of your physics life that delta means expanded into final minus initial. Okie dokie? Cool, on test. So your next equation, ladies and gentlemen, is our next equation on our list. So D is equal to VIT plus 1/2 AT squared. So our displacement is equal to our initial velocity times time plus 1/2 times A times time squared. Okay. And then we are also going to have our distance, our displacement, is equal to our final velocity times the time plus, whoopsie, there we go. Let's get that fixed, minus 1/2 AT squared. These 2 equations are very similar. What are the 2 differences? Good. VI, VF, plus, minus. We are going to be looking at how to rearrange these equations in a little bit here, but watch out for those 2. Those are a pain in the butt to rearrange. Of all of the equations that we use with acceleration, these 2 are the ones I see rearranged incorrectly the most. So watch out for those. Really, really take your time and focus on those and really work with that reverse bed mass. Okay, so our next equation is our VF plus VI over 2 bracket times time. There's that equation. So VF, final velocity, initial velocity, divided that by 2, multiply by time. That gets you your displacement. And then there's this guy. So your final velocity squared is going to equal your initial velocity squared plus 2AD. This is another one that's a bit tricky to rearrange, so watch out for that. Okie dokie? All right. So, and then what we also have here as well, of course, this doesn't want to scroll. Oh, come on, computer. There we go. So there's your list of all of what the letters represent and all of their units, the standard units. So for your displacement, it's in meters, time, seconds. VF and VI, their units are in meters per second. Now look out for the units on this guy. Okay, notice it's meters per second squared. These are just the units. Okay, you do not have to square acceleration unless the equation says so. Those are just the units. Watch out for that. Okay, really watch out for that. So another couple of things to look out for is that a lot of these are vectors. So these guys are vectors. This guy is a vector. So because these are all vectors, they need direction. So that means that you're going to need to really watch for your signs, okay? So for your positive and negative signs, these are vital, okay? On test, put lots of stars. Watch those positives and negatives, okay? It's going to become super important as we get farther and farther into the course, or your positive and negatives, depending on what direction you're going. It's going to be super important. All right? Okay. So, ladies and gentlemen, so how do you know what equation to use? There's a lot of equations. I know it probably feels like you're drinking out of a fire hose right now. It's like, oh my gosh, so many equations all at once. So, your trick, ladies and gentlemen, 1, read your question. As you're going through each question, highlight every time you see a number and write it down, like list out every variable that you have with its appropriate letter. Once you have that list, then you can go and look at your data sheet and then pick which ones you need, okay? So by doing that, you'll also be able to see to use whichever variable you don't know and don't want or need to know. Well, if you have for example, you're trying to find acceleration, and you've got VF and VI in time, you don't have displacement, well, guess what? There's one equation in there that doesn't have displacement. You can use that one. Okay. I'll go over that one a little bit more practically when we start looking at our lovely practice problems. Okay. I want you guys to circle this. You can never use this equation for accelerated motion, okay? This is something that has caused a lot of grief for a lot of kids over the years, so watch out for this. If you use V equals D over T in a question that has anything to do with acceleration, I'm going to cry inside a little bit, okay? This equation is for uniform motion only. Okay, that's for uniform motion only when we're not accelerating. So please do not use this equation with acceleration. Only use that equation for uniform motion scenarios. Okay, guys? Cool. All right. So, a couple other pieces of things that you need to use. Now, ladies and gentlemen, the thing is that the plus and the negative sign does not necessarily indicate the direction is moving. It tells us whether the object is speeding up or slowing down. Okay? The plus and the negative sign for acceleration does not tell you the direction the object is moving. Okay? So positive acceleration is when an object is speeding up. Okay? All right. So what we're going to do here is I'm going to draw an object. We've got a car. There's a car. Aren't you glad I don't teach you guys art? I'm glad I don't teach you art too. As I've taught art before. I know. It was not a good time for anybody. We all struggled. Okay. So here's our car. Your car is moving with a velocity going forward. Okay? All right. Well, as you are moving forward, you are going to step on the gas and you accelerate. Okay? Well, in this case, you're moving forward, but you speed up. Because you are speeding up and you're going faster, you are going to have positive acceleration. Okay? Well, notice that these two direction vectors here, you're going east, you step on the gas, and you go faster east. You're accelerating east. You are speeding up. Okay? Okay. So, ladies and gentlemen, you're still going east. Now, this is, if you're going to be slowing down, ladies and gentlemen, if you are going to be slowing down, you're going to have negative acceleration. Okay? So I'm going to draw another car here. Okay. You're motoring along. Okay, you're scooting down the highway. There's your velocity arrow, your vector arrow. You're going forward. You're driving. However, guess what? You see a deer on the road because this is northern Alberta. You slam on the brakes and you start slowing down. Because you are slowing down, your acceleration is going in opposite direction to the way you are going. Think about when you're driving. Okay, quad, dirt bike, car, pedal bike, whatever vehicle you are on, you're moving forward and you hit those brakes. You slow down, but you are still moving forwards. Okay? You're still moving forwards. Because you're still moving forwards, if you're moving east, your displacement is still east, but you're slowing down. Okay? So your displacement's going forward. Your motion's going forward. You're just going more slowly. Your acceleration is going backwards while you're going forwards. Okay? So very, very important, guys. Okay? Keep that in mind. Okie dokie. All right. So, ladies and gentlemen, we can also think about this in a couple of different ways. Remember how we talked about how east is most of the time positive and north is most of the time positive and west and south are most of the time negative? Well, the thing about acceleration here is, now these are bits that we don't often use, but I'll still talk about them anyway. So here's another vehicle. We're going to assume they're not on a collision course here. Let's say you're going this way. Okay. And then your acceleration is going this way. So this, let's label this. This is going to be west and this is going to be east. Well, here, because we are going east, well, that's positive. That's positive. Okay, good. Okay, we're speeding up. That's positive. Well, we're going west. What does this do? Well, in some scenarios, you can hear, well, if you were going to wind up having, okay, well, that's going to be negative because you're going that particular direction. Well, if you are going to make this negative, well, guess what? In some cases, we're not really going to use this much, but that could be negative. They're both negative. They both have the same sign connotation here. Well, guess what? Because they're both going in the same direction, that gives us positive. Okay? Technically. We're going to be going to the west. The arrows are going in the same direction. You're going to have positive acceleration. You're going to be speeding up. Okay? So, same idea over here. And if we flipped this thing around, we would then have notice, well, they're still going in opposite directions, so you're going to have negative acceleration. Okay? Okay. So you're going to have to be careful with your signs. Remember, you can absolutely make west and south positive if that's the direction you're starting in, and just kind of adjust the scenario as you go. Okay, but you just have to remember what direction you're going to be assigning as negative and positive when you start. Okay, I know it's tricky, guys. These sign connotations are so tough, so confusing. Just keep trucking. You'll get there. All right, so let's look at a few practice calculations here, ladies and gentlemen. I'm just going to scroll down to make sure I get my data right. Got all the answers all scanned up on this computer. In case you guys haven't figured this out, I'm filming all these videos out of order. Because of COVID, I started filming in the middle of the unit, like right in dynamics. When we start dynamics is when I start filming this, because when the schools shut down back in March, we were doing dynamics. Well, then in June, at the end of the year, I went back and started filming kinematics. And now here we are in July. Yeah, this is my summer vacation. I'm doing this unpaid right now because you guys are awesome. And I want to give you guys educated because when we're back in September, who knows what's going to happen. So I'm going to have a full set of videos. So we're in July right now. So I just got my computer screen over here. All my school books are at school in my filing cabinet. So I've scanned all the answers to these, and they're on my computer. So I got this computer and the writing tablet, the computer over here. I know. It's nuts, guys. Nuts, I tell you. Okay. There we go. So I feel really fancy with like 2 computers and the fancy Wacom writing tablet, which the Chromebook is my husband, and the Wacom tablet I borrowed from Mr. McLeod, and then I got my, crummy computer over here. Yeah. It's great. It's nuts. Okay. Back on topic. But what would a physics lesson with me be if I wasn't off topic doing something goofy at some point? It's what we do. It's fine. All right, guys. So remember how I mentioned that list out things that you have. Now, I know I would have talked about this earlier when we were using V equals D over T, and you guys were probably sure, Mrs. Bray, and I know how to do this three-letter equation. It's all fine. But now we got pain coming, guys, because we got 5 equations to pick from, and I'm not telling you which one to pick. You got to figure that out yourselves. So by doing that, by doing this trick that I'm going to show you, and if you do it properly and don't slack off, you are going to be able to answer this question a lot easier. Okay, so trust me on this. List out what you have, organize your data properly, and it's going to make your life so much easier. Okay, as I know these questions are tricky, so definitely show your work the way I'm showing you, and your life would be simpler. Help me help you get the most marks possible by showing your work. And how I am showing you work here and now is the really best way to show your work to me to help you get the most marks and to make sure you get the most points on your question by not making a mistake like getting the wrong equation. So help me help you get the most points possible here. Okay, it sounds like a sales pitch. All right, so an object accelerates. So keyword accelerates. All right. Can you use V equals D over T? No, if you use V equals D over T, I will cry. Okay. Accelerates north uniformly from rest. Okay, pause for a sec. Rest. What does that mean? We use this a ton in physics, by the way. Stop. It means stop. It means you're not moving. From rest. From rest means we are starting at rest. Now, when we say the word rest, that's going to give you your velocity. If you're stopped, do you have velocity? No, you don't. From rest means we're starting at a stop. So, it sounds so funny, starting at a stop. So your VI is going to be 0 meters per second. Now, because I said the word rest, I haven't actually given you any sig digs. It's an absolute value. You're not going anywhere. So this guy here, 0 meters per second, actually doesn't count towards sig digs because I didn't give you sig anything here. Okay? So the word rest does not imply a number of sig digs. You do not take that into account. Okie dokie? Okay. In a time of 2.7 seconds, In this time, the object traveled 2 meters. Okay, well, that's its displacement. It's going 2 meters north. Okay, what was the final velocity? Okay, well, VF equals question mark. Well, ladies and gentlemen, you notice you now have 4 variables here. V, I, T, D, and VF. Remember, with an acceleration equation, each equation is going to have 4 out of the 5 variables. So this is the trick on how to know which equation you're going to pick. So notice I've read the question. I've taken my time reading that question. I've picked out all of the data, and I've written the numbers down that I need in a list like this. Okay. Now, this is where I'm going to pull up my data sheet. I'm going to see those 5 pink equations, those 5 highlighted equations. You're going to look at these. You need to have each of these and none of the other letters you don't have. So, well, my first equation, well, it has A in it. Well, I don't have A, so I'm not even going to look at the rest. D equals VIT plus 1/2 A. Okay, A, can't use that one. D equals VFT minus 1/2 A. Nope, can't use that. D equals VF plus VI over 2 times time. Hey, that one's got all my variables. That one doesn't have A. Pretty good. I'm just going to double check the last one just to be sure. VF squared plus V equals VI squared plus 2AD. No, can't use that one. Okay, so notice how I did that. I went through each of my acceleration equations and I picked the one that has all of the variables I need. Well, in this case, it's D is going to equal VI plus VF over 2 brackets times your time. Now, when you're showing your work, ladies and gentlemen, and I know I'm sure I've harped on this before, but it's super important. Please remember, on test, and any time you're going to hand anything in to me to mark, you have to show your work and you have to show it well. And if you don't do this, I'm not going to take off points directly. If you don't make this list, I'm not going to take off points directly, but trust me, guys, I just finished my 9th year of teaching. I know, hard to tell, baby face, right? So I've been doing this for 9 years. And there's a direct correlation between the students who get their questions right and the students who list out their variables like this. So if you do this, you're more likely to get the question right because you're more likely to pick the right equation. And you're more likely to put the right numbers in the right spot in the equation. Okay? So if you don't do this when showing your work, you're going to be at an increased chance of getting the question wrong. Okay? But I don't deduct points if you don't do it. Okay? You have to write out your equation. You don't write out your equation, I deduct points. Okay? The next thing you're going to do is you're going to rearrange your equation. Okay? So for something that's multi-step, write it down. Just show your work. So let's rearrange our equation. So what is the final velocity? Well, I got to isolate for VF here. Now remember, when we're rearranging our equations, we do reverse BEDMAS. Okay? So subtraction, addition, there's none of that here. Multiplication, division. Okay, well, we have to work outside the brackets first. So we have this time. So, ladies and gentlemen, I'm going to divide both sides by time. Okay, so we have D over T as equal. Now by that, we will have our brackets just left, so we can break those brackets open, and then we can go from there. All right. Oops. So ladies and gentlemen, another thing to keep in mind when rearranging equations is anything that is on top of that dividing line, we assume is in parentheses or brackets. So see this guy here? I put those blue brackets there. We assume that all of the equations in that numerator position on top of that dividing line, they're in brackets. So we have to deal with this 2 first. I'm going to multiply by 2. That cancels. Multiply by 2. So now I have 2D over time is equal to VI plus VF. Now I want to show you guys a trick here. What's your VI? 0. So you have a VI of 0, ladies and gentlemen. Now, because you have a VI of 0, I'm just going to cross it off. It's 0. It cancels. Save yourself the work of subtracting VI over. It's 0. Done. Okay. Now remember, ladies and gentlemen, it's 0 plus VF. 0 plus VF is VF. When you're dealing with 0, be careful with your operations, okay? 0 plus VF is 0, but 0 plus VF is VF, excuse me. But 0 times VF is 0. So you got to watch for that, okay? All right. So our VF now is going to equal 2D over time. All right. So when it comes to helping me help you get the most points possible, you are going to now, having written out your equation, having rearranged your equation, now you're going to put your numbers into your equation. So, well, VF is what I'm trying to find. So I need 2. And okay, this is where we're going to have to think carefully about our directions. Okay, the object is traveling north. Well, that's positive, right? Okay. So we're going to make sure that we have our positive 2. Time is scalar, so we don't need direction for scalar. That's going to be left as positive, 2.7 seconds. Okay. So on your calculator, you're going to plunk in. You know what? Did you guys catch where I screwed up? I dropped 0. It's not 2, it's 20. I hope you guys were paying attention and you caught that. Good job, guys. So 40 over 2.7, you are going to get your 1 or 14.814 ... Okay. Well, ladies and gentlemen, you've done that. You now need to be communicating your answer properly here. So we need units, sig digs, and velocity. Is velocity a vector? Yes, it is. So I want direction. I want units, sig digs, direction. You have to have all 3 of these things along with the correct number in order to get your final answer correct. So now, why does all this matter? Why am I harping on about sig digs and units and direction, blah, 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 blah? Why does it matter? I'm pretty sure I already told this to you in a previous video. So, ladies and gentlemen, why does it matter? So your bridges don't collapse when you're an engineer. There was this bridge in Edmonton that had to be shut down in the middle of construction and cost the government millions and millions of dollars because an engineer made an error with his significant digits. Yeah, he rounded wrong. So the whole bridge had to be redone. So people's lives hang in the balance on the physics of engineers. So if you're thinking of being an engineer, your sig digs matter, guys. Your directions of your forces matter, right? So it's going to be important. So we're going to start hammering this stuff into your brains right now. And when you think that Mrs. Bray is super cruel and mean for taking points off for sig digs, when you guys are engineers and people live because your sig digs are done correctly, maybe you'll thank me then. Okay. So ladies and gentlemen, sig digs, important because lives hang in the balance. We need to look at rounding these guys. So I've got 3 sig digs here, 3 sig digs here. Okay. So that means my answer must have sig digs. Remember, the word rest does not have sig digs. So I'm going to round to 3 sig digs. Okay, well, that's going to round down, so 14.8. Your units are meters per second. We wound up with a positive answer. Okay, so that means, what was our initial direction going? North. Okay. You got your correct sig digs. You have your units in meters per second. You have your direction of north. Please underline or box your final answer if it's a test or an assignment. So I know what you want me to mark as your final answer. It's so much easier. It saves me time, and more importantly for you guys, it prevents me from making marking mistakes and marking the wrong number that you want. If you want me to mark like a partial answer like this guy, if this isn't clearly stated somewhere, there's been times I've marked that partial answer because I didn't find your final answer. As well, please make your work neat. Make your writing neat, legible, please, 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 and organize your work properly, right? If I can't read it, I can't mark it. And if I have no idea what's happening on your page because your numbers are everywhere, I'm going to have a very difficult time figuring out what's going on as well, especially if you make some tiny little mistake like a calculator error and the answer is wrong. If your numbers are everywhere all over the page and there's no neat organization system of columns or something, then I won't be able to mark it as effectively. So please, please, please make your work neat. All right. And in university, some profs, they won't even look at your stuff if it's messy. If they can't read it, they just give you 0. Okay. So make your work neat, please. All right. Please make your work neat. All right. So that's our first equation. We've got another 2 to look at before you do your practice problems. So for these next 2, I'm not going to spend as much time going over again and again and again what I'm looking for with showing your work. I'm just going to do the things when it comes to showing your work and your final answer for units, sig, digs, direction for vectors. Okay, so I'm going to do them, I'll mention them, but I'm not going to spend the same amount of time nagging you about them. Okay. So, ladies and gentlemen, a golf ball is hit from a tee box. The golf ball has a speed of 4.6 meters per second as it strikes a tree. Okay. Well, that's what it's starting at. So it's VI is our 14.6 meters per second. The golf ball bounces straight back off the tree with a speed of 11.3 meters per second. Okay. I'm going to pause here. If I leave my numbers like this, I have made a mistake. What would that mistake be? See if you can find it. Negative. I dropped a negative. Ladies and gentlemen, this guy here, this 14.6, is going towards a tree. It bounces off the tree, and then it's coming backwards off the tree. So this guy's going forward. This guy's going backwards. Okay? So, ladies and gentlemen, you guys really, really, really got to make sure that you watch those directions, okay? Okay, it's really important. It's going to change everything you do that happens with your question. Okay, it really matters. All right. So, with the speed, if the golf ball is in contact with the tree for 84 milliseconds, what is the acceleration of the golf ball? Okay. Now, we also have another thing we got to do here. We've got 84 milliseconds. Can we do math in milliseconds here? Nope. We've got meters per second, meters per second. We're dividing by seconds here, and we got milliseconds. Wrong units, can't do it. We have to convert units. So we are going to multiply this by your 10 to the power of negative 3, seconds per 1 millisecond. Your milliseconds cancel. You're left with seconds. I'm just going to erase this and write this underneath here. It'll be easier to write. So we're going to have our 8.4 times 10 to the power of negative 2 seconds. I'm trying to find acceleration. So when it comes to finding out what equation you need, you're going to look at your data sheet and you're going to see, well, I've got A, T, VF, and VI. Well, but wait a minute. That's not on my data sheet. What do I do? You guys found the problem? Delta. All right, because you've got your equation of acceleration is equal to delta V over delta T. So what this means, delta means you have to expand that, or can expand it if the equation allows. Well, here it absolutely does. Okay, so VF minus VI over delta T. When you have that delta, expand it into VF minus VI. Okay, super important. That will haunt you for the rest of your physics life. Okay, so ladies and gentlemen, do I need to rearrange this equation? No, I don't. Awesome. Life is going to be a bit easier. So VF is going to be our positive 14.6 minus your negative 11.3. Don't drop that negative, guys. We are going to divide this by our time of 8.4 times 10 to the power of negative 2 seconds. And once you plonk that value into your calculator, you're going to get a value of negative 308.33 ... meters per second squared. Okay, so we need to now put this value into your beautiful calculators. Oh, it's already in your calculator. Let's try this again. You need to put this value into sig digs and units and direction. Okay, so let's see what we got for sig digs. Well, I've got 3 sig digs here, and I've got 3 sig digs here, and 2 here. That means my number must be in 2 sig digs. I need to round that number. Well, this one's going to be a bit trickier because, well, look, I've got 3 digits before outside that decimal. So that means, ladies and gentlemen, I have to put it in scientific notation. And I'm going to have to round. I need 2 sig digs. So I'm going to go look at this third. Well, there's an 8. That 8 is going to round that. So I'm going to have, and then I have to move it 2 places. So 3.1 times 10 to the power of 2. Okay. Units, we're accelerating. The units are meters per second squared. Those are just the units. Don't square anything. Those are just the units. All right. So now, ladies and gentlemen, I'm still losing myself half a point here. What am I missing? I didn't take into account my direction. I asked for the acceleration of the golf ball in the question and acceleration's a vector. That means you must have direction in order to get your final answer correct. So, I didn't say north, south, east, or west. But I can give a more ambiguous, I wouldn't say ambiguous, a more less formal direction. That's the word I'm looking for. So, well, it was moving towards the tree initially. Well, now it's moving away from the tree. So let's go away from tree. Please box your final answer. Okay, so those are all the pieces that I need to see to get full points on this question. Sounds good? Awesome possum. Last one, ladies and gentlemen. Okay. A vehicle traveling along the highway suddenly brakes to avoid hitting a deer. It's a thing, guys. So keyword, suddenly brakes. We're slowing down. The vehicle decelerates at 3 meters per second squared. Technically speaking, guys, deceleration isn't really a physics thing. It's negative acceleration is the proper term, but we'll go with it. So it decelerates at a rate of, okay, so its deceleration is 3 meters per second squared. It's slowing down. This car is slowing down. What do I need to do with that 3? Make a negative. Okay, don't forget your signs. Watch closely, guys. watch closely for that. To a speed of 60 kilometers an hour. Okay. It decelerates to a speed. Note that keyword to. Watch your froms and twos, ladies and gentlemen. Watch your froms and twos. That's going to tell you if it's final or initial. It decelerates to a speed of 60 kilometers an hour. Okay. So that means VF ladies and gentlemen, can I do my math in this? It needs to be meters per second. So let's just convert this right now. Okay, so we are going to we can do either time or distance first. Well, let's get rid of, let's deal with our time first. So 3,600 seconds in 1 hour. Hours cancel. And then I'm going to deal with my distance. So I want my 1,000 meters in 1 kilometer. So that's going to give me a VF of 16.6 repeating meters per second. Ladies and gentlemen, leave that number in your calculator. If you use just 16.6 enter in your calculator, you're going to get the question wrong because your numbers are going to be off. You always round at the end. So because we now have an intermediate number, you use every single one of those digits in your calculator, in your equation. All right? Okay. So what else do we have? According to the skid marks on the road, the vehicle skidded for a distance of 56.3 meters. Based on this information, what was the initial speed of the vehicle? Okay. Let us begin. So let's look at the equation here. Let's see what we got. We have acceleration, VF, distance, and VI. Well, when you go look at your data sheet, the equation that we've got here is our VF squared is equal to VI squared plus 2AD. Well, we are trying to find VI. Well, now that we've got VI here, ladies and gentlemen, we got to rearrange this guy. Watch out for these plus and negative signs in the middle of these equations. Remember, when we're rearranging these guys, we got to go with reverse bed mass. Okay. If you're still having a hard time with rearranging equations at this point, please make sure you come and see me and we can do some work on it. Okay. So come to focus block, or I don't know what's happening in the world. Like, we still haven't even reached the August 1st date at the time of the infamous August 1st date where the government's going to be announcing stuff, at the filming of this video. So if we're still at home, then send me an email, Google Meet, or we can Google Meet and go over it. Or if we're at school, come see me in focus block, or however focus is going to work when we get back. I don't know, guys. I don't know. Guys, it's stressful for me as it is for you, trust me. So, but if you're still having, but to the point, if you're having a hard time rearranging equations, get a hold of me in some fashion and we will go over it. Cool beans? Cool beans. What you could also do is go back and watch that section on rearranging equations in the review video. Watch that again and again and do some practice problems there. You can do that too. That's good. So we have to go reverse bed mass. When we go reverse bed mass, we have addition and subtraction here. So I have to deal with this addition and subtraction first. But ladies and gentlemen, remember to math. These guys are all squashed together with no equation between them. That means they're being multiplied. They're in a chunk. You have to keep them together. So that means when I'm going to be rearranging this equation, I need to subtract the entire 2AD. Okay? I have to get rid of this whole piece together. Okay? So subtract 2AD on either side. So I'm going to have VF squared minus 2AD is going to equal VI squared. Okay. Now what do we do? Square root. So this is squared, so you got to square root this to get rid of that squared. and then square root the whole lot of this. But wait, you ask, does this square root cancel out this squared? No, it doesn't. It doesn't because of the subtraction. Okay? All right. So our VI is going to equal the square root of VF squared minus 2AD. Cool beans? Okay. Now that we have our equation rearranged, I am then going to plonk my numbers in. So my VF is 16.66. Repeating. Ladies and gentlemen, use that entire number in your calculator. Okay, like go back on your fancy graphing calculator, scroll back, hit enter, square that answer. Okay, just use the whole 666 repeating. Okay, minus 2 times your A, which is negative 3. Okay, and then you have the displacement, which is your 56.3 meters. Square root the lot. Ladies and gentlemen, be careful putting this in your calculators, okay? Do not do this all in one piece. Break it down, okay? Take this number, square it, hit enter. Second answer, minus, bracket, 2 times negative 3 times 56.3, bracket, enter. Okay, because you got to put this in improper bed mass, guys. You got to put this in improper bed mass. Then second square root, second answer. Okay. Notice that if you forgot this negative here way back at the beginning, you have this guy subtracted by this. You are going to be at risk of winding up subtracting taking a square root of a negative number. And that's not going to fly. So watch those negatives, because there will be cases that you might wind up with a scenario where you're taking the square root of a real number or an imaginary number, because the square root of a negative is imaginary, right? So you might, if you square rooting a negative, you've made a mistake with your direction at some point. So watch out for that. Once you've put this equation or this into your calculator correctly, that's another really common thing I see as stuff being put into calculator wrong. So if you're having an issue with that, make sure you talk to me and we can work our way through that. Okay, so you're going to get your final answer once you put this into your calculator, 24.8108 ... Okay, sig digs, unit. And I said initial speed. Ladies and gentlemen, notice I said speed. Is speed scalar or vector? Scalar. Do I want a direction? No. So I just need sig digs and units. So 24.8. How many sig digs do I want in this question? I'm going to go back to the original question. Well, I've got 3, and I've got 2, and I've got 3. So I need 2. So I need 2 sig digs. So that means I'm going to come over here. All right, I'm going to do my rounding. We'll look at this third sig dig. That's 8. So that's going to round that up to 25. Our units are meters per second. I said scalar, so I don't want direction. 25 meters per second. All right. So ladies and gentlemen, I hope you guys found that video helpful. Hope you guys enjoyed it. In your workbooks, the same ones I gave to you at the beginning of the year, I got a pile of practice problems here. You see all these guys here. Give some of them a try. Lesson subtle hint. These equations are going to be haunting you for pretty much the rest of the course. Please practice them. Please, please, please get comfortable with rearranging them. Do a bunch of those questions, check your answers, see how you do. If you need any help, make sure you ask for help in whichever method we are using at the time you are watching this video. Because I don't even know what we're going to be doing in September. I got no idea. Just remember, at time of filming, this is July. Like, what is it? Like July 15th. So, been out for like 2 weeks and I'm already back working. Miss you guys. All right. So, ladies and gentlemen, Hope you guys enjoyed that, found it helpful. Please be so kind as to do your practice problems. We'll see you guys later. No fires, injuries, or explosions. Talk to you later.